Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on Pigeonhole principle, lecture number 3, in which I will solve some problems on Pigeonhole principle. Now we solve a problem. Problem is so that 7 colors are used to paint 50 cars. At least 8 cars will have the same color. Now we solve this. Here number of cars equal to 50. We may compare this with pigeons. And number of colors equal to 7. We may compare this with pigeonhole. This is the set of cars and this is the set of pigeonholes. F be the mapping defined on the set of cars into set of colors. Therefore, by pigeonhole principle, (50 minus 1 by 7) greatest integer function plus 1 number of cars will have same color, since greatest integer function 50 minus 1 by 7 plus 1 equal to 49 by 7 greatest integer function plus 1 equal to 7 greatest integer function plus 1, and greatest integer function of 7 is 7. This is 7 plus 1 equal to 8. Therefore, 8 number of cars will have same color. That means a color will be the image of 8 cars. That is, one pigeonhole contains at least 8 pigeons. Cars are compared with pigeons. Now we solve the next problem. Problem is how many letters one must choose from the set of 15 A's, 20 B's and 25 C's, so that 12 identical letters will always be included in the selection. Here we have 3 kinds of letters. These 3 kinds may be compared with three pigeonholes, since each kind of letters are more than 12. We have to select 12 identical letters and put in a pigeonhole. Let numbers of letters to be taken equal to n. Therefore, by pigeonhole principle, greatest integer function n minus 1 by kinds of letters, number of pigeonholes be 3 plus 1 equal to 12, implies that greatest integer function n minus 1 by 3 equal to 12 minus 1, implies that greatest integer function n minus 1 by 3 equal to 11, implies that n minus 1 equal to 11 multiply 3, implies that n equal to 33 plus 1 equal to 34. So we choose 34 letters so that 12 identical letters always be included in the selection. So answer is 34. Now we solve next problem. Next problem is 10 people came forward to volunteer for a 3-person committee. If every possible committee of 3 that can be from these 10 names written on a slip of paper, one slip for each possible committee, and the slips are put in 10 hats so that at least one hat contains 12 or more slips of paper. Now we will have to form 3 members committee among 10 people. So number of committees will be equal to 10C3. We select 3 persons among 10 people, and this is equal to factorial 10 by factorial 3 factorial 10 minus 3, and this will be equal to 120. Let the first set contains different committees. Number of committees be 120. Here C 120. And second set be the 10 hats FBA mapping. We have to show that in a hat there will be 12 slips, means each slip contains 3-man committee. So we compare these committees by pigeons and hats. Pigeonhole. Number of hats equal to 10, means 10 pigeonholes and 120 pigeon. Therefore, by pigeonhole principle, (120 minus 1) by number of pigeonholes, that is 10, greatest integer function plus 1 number of slips will be at least one hat. Since greatest integer function 120 minus 1 by 10 plus 1 equal to 119 by 10 greatest integer function plus 1, and this will be equal to 10 11 just 110, and here 9 by 10 greatest integer function plus 1, value of this greatest integer function is 11. Since we have to find the integers less than or equal to this, and we have to select among these the greatest, that is 11 plus 1 equal to 12. Therefore, there will be at least one head which will contain at least 12 sleeves, that is 12 or more than 12 sleeves. Proved. Now we solve the next problem. Next problem is, let T be an equilateral triangle whose sides are of length 1 unit, so that if any 5 points are chosen lying on or inside the triangle, then 2 of them must be no more half unit apart. Now we solve this. Let ABC be an equilateral triangle such that length of AB equal to BC equal to AC equal to 1. Let D, E, F are middle points of sides AB, BC and AC respectively. Let us join DE, EF and DF. Since AD equal to BD equal to BE equal to EC equal to CF equal to AF equal to half. Therefore, we get 4 equilateral triangle such that sides of each equilateral triangle equal to half unit. This is 1 unit and this is half unit. So here we have number of equilateral triangle before equal to 4. We may compare this equal to number of pigeonholes. Since there are 5 points which will lie on or inside the triangle. Here points may be compared with pigeons. So number of pigeons equal to 5, number of pigeonholes 4. So one pigeonhole must contain, therefore one pigeonhole will contain greatest integer function 5 minus 1 by number of pigeonholes 4 plus 1. Pigeons means points. Pigeons means points. This is at least. This equal to 5 minus 1 equal to 4, 4 by 4 equal to 1. So value of this greatest integer function is 1 plus 1 means 2 points. Means here we have 4 equilateral triangles and one equilateral triangle will contain 2 points. Distance between these 2 points must be less than half. That is, one of these 4 equilateral triangles will contain at least 2 points. Since length of the side of each equilateral triangle equal to half. Therefore, distance between 2 points lying on or inside an equilateral triangle will be less than half unit. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.